In this book, most of my examples use handwritten code. With simple and repetitive mapping, this can lead to code that's simple and repetitive. And repetitive code is a sign of something wrong with the design. There is much you can do by refactoring out common behaviors with inheritance and delegation. Good, honest practices. But there's also a more sophisticated approach using metadata mapping. Metadata mapping is based on boiling down the mapping into a metadata file that details how columns in the database map to fields in objects. The point of this is that once you have the metadata, you can avoid the repetitive code by using either code generation or reflective programming. Using metadata buys you a lot of expressiveness from a little metadata. One line of metadata can say something like, from that, you can define the read and write code, automatically generate ad hoc joins with all of the SQL, and foster multiplicity of the relationship. And even do fancy things like computing write orders under the presence of referential integrity. This is why commercial overmapping tools tend to use metadata. When you see metadata mapping, you have the necessary foundation to build queries in terms of in-memory objects. A query object allows you to build the queries in terms of in-memory objects and data in such a way that developers don't need to know either SQL or the details of the relational schema. The query object can then use the metadata mapping to translate expressions based on object fields into the appropriate SQL. Take this far enough and you can form a repository that largely hides the database from view. Any queries to the database can be made as query objects against the repository, and developers can tell whether the objects were retrieved from memory or from the database. Repository works well with rich domain model systems. Despite many advantages of metadata, in this book I've focused on handwritten examples because I think they're easier to understand first. Once you get the hang of the patterns and can handwrite them for your application, you'll be able to figure out how to use metadata to make matters easier. Database connections. Most database interfaces rely on some kind of database connection object to act as the link between application code and the database. Typically, the connection must be opened before you can execute commands against the database. Indeed, usually you need an explicit connection to create and execute a command. The whole time you execute the command, the same connection must be open. Queries return a record set. Some interfaces provide for disconnected record sets, which can be manipulated after the connection is closed. Other interfaces provide only connected record sets, implying that the connection must remain open while the record set is manipulated. If you're running inside a transaction, Usually the transaction is bound to a particular connection, and the connection must remain open while it is taking place. In many environments, it's expensive to create a connection, which makes it worthwhile to create a connection pool. In this situation, developers request a connection from the pool and release it when they're done, instead of creating and closing the connection. Most platforms these days give you pooling, so you rarely have to do it yourself. If you do have to do it yourself, first check to see if pooling actually does help performance. Increasingly, environments make it quicker to create a new connection, so there's no need to pool. Environments that give you pooling often put it behind an interface that looks like creating a new connection. That way, you don't know whether you're getting a brand new connection or one allocated from a pool. That's a good thing, as the choice to pool or not is properly encapsulated. Similarly, closing the connection may not actually close it, but just return it to the pool for someone else to use. In this discussion, I'll use open and close, which you can substitute for getting from the pool and releasing back to the pool. Expensive to create or not, connections need management. Since they're expensive resources to manage, they must be closed as soon as you're done with using them. Furthermore, if you're using a transaction, usually you need to ensure that every command inside a particular transaction goes with the same connection. The most common advice is to get the connection explicitly using a call to a pool or connection manager, and then supply it to each database command you want to make. Once you're done with the connection, close it. This advice leads to a couple of issues. Making sure you have the connection everywhere you need it, and ensuring that you don't forget to close it at the end. To ensure that you have a connection where you need it, there are two choices. One is to pass the connection around as an explicit parameter. The problem with this is that the connection gets added to all sorts of method calls, where its only purpose is to be passed to some other method 5 layers down the call stack. Of course, this is the situation to bring up a registry. Since you don't want multiple threads using the same connection, you'll want a thread scoped registry. If you're half as forgetful as I am, explicit closing isn't such a good idea. It's just too easy to forget to do it when you shoot. You also can't close the connection with every command because you may be running inside a transaction, and the closing will usually cause the transaction to roll back. Like a connection, memory is the resource that needs to be freed up when you're not using it. Modern environments these days provide automatic memory management and garbage collection. So one way to ensure that connections are closed is to use the garbage collector. In this approach, either the connection itself or some object that refers to it closes the connection during garbage collection. The good thing about this is that it uses the same management scheme that's used for memory, and so it's both convenient and familiar. The problem is that the close of the connection only happens when the garbage collector actually reclaims the memory, and this can be quite a bit later than when the connection lost its last reference. As a result, unreferenced connections may sit around a while before they're closed. Whether this is a problem or not depends very much on a specific environment. On the whole, I don't like relying on garbage collection. Other schemes, even explicit closing, are better. Still, garbage collection makes a good backup in case the regular scheme fails. After all, it's better to have the connections close eventually than to have them hanging around forever. Since connections are so tied to transactions, a good way to manage them is to tie them to a transaction. Open the connection when you begin a transaction and close it when you commit or roll back. Have the transaction know what connection it's using so you can ignore the connection completely and just deal with the transaction. Since the transaction completion has a visible effect, it's easier to remember to commit it and to spot if you forget. Unit of work makes a natural fit to manage both the transaction and the connection. If you do things outside of a transaction, such as reading immutable data, you use a fresh connection for each command. Tooling can deal with any issues in creating short-lived connections. If you're using a disconnected record set, you can open the connection to put the data in the record set and close it while you manipulate the record set data. Then, when you're done with the data, you can open a new connection and transaction to write the data out. If you do this, you'll need to worry about the data being changed while the record set was being manipulated. This is a topic I'll talk about with concurrency control. The specifics of common management, connection management, are very much a feature of your database interaction software, so the strategy you use is often dictated by your environment. Some miscellaneous points. You'll notice that some of the code examples use select statements in the form, while others use named columns. Using select can have serious problems in some database drivers, which break if a new column is added or a column is reordered. Although more modern environments don't suffer from this, it's not wise to use select if you're using positional indices to get information from columns, as a column reorder will break code. It's okay to use column name indices with a select, and indeed, column name indices are clear to read. However, column name indices may be slower, although that probably won't make much difference given the time for the SQL call. As usual, measure to be sure. If you do use column number indices, you need to make sure that the accesses to the result set are very close to the definition of the SQL statement, so they don't get out of sync if the columns are reordered. Consequently, if you're using table data gateway, you should use column name indices, as the result set is used by every piece of code that runs a find operation on the gateway. As a result, it's usually worth having simple create, read, update, delete test cases for each database mapping structure you use. This will help catch cases when your SQL gets out of sync with the code. It's always worth making the effort to use static SQL that can be precompiled rather than dynamic SQL that has to be compiled each time. Most platforms give you a mechanism for pre-compiling SQL. A good rule of thumb is to avoid using string concatenation to put together SQL queries. Many environments give you the ability to batch multiple SQL queries into a single database call. I haven't done that for these examples, but it's certainly a tactic you should use in production code. How you do it varies with the platform. For connections in these examples, I just conjure them up with a call to a DB object, which is a registry. How you get the connection will depend on your environment, so you substitute this with whatever you need to do. I haven't involved transactions in any of the patterns other than those on concurrency. Again, you need to mix in whatever your environment needs.